So we've just completed discussing the theory of long-run purchasing power of currencies in different countries, which helped us to understand how exchange rates are determined. We learned that the purchasing power parity implied both absolute purchasing power parity as well as relative purchasing power parity. And one helped us to explain that the ratio of prices of two nations determined exchange rates, and the other one, the relative purchasing power parity, helped us to understand how the appreciation and depreciation of exchange rates were explained by the differentials in the inflation rates in the two countries. But all of this begs the question of why do prices? I mean, what prices may have impact as well as inflation may impact the exchange rates, but for heaven's sakes, what impacts the prices and what impacts the inflation rate? So to really get a good understanding of exchange rates, we really need to understand how monetary conditions can impact countries and how price levels are related to monetary conditions. And so we'll put both of these ideas together, and that will ultimately develop a long-run theory known as the monetary approach to exchange rates. So let's finish the last leg of this model. So let's begin by talking about various kinds of money in the economy. We have currency that's in circulation. We have base money, that's currency in circulation, plus the private cash reserves in banks. We also have what's referred to as M1 narrow money, and this also includes this currency in circulation again, but it also includes demand deposits, the deposits you put in your bank, traveler's checks as well, and other highly liquid deposits. And then finally we have what's referred to as M2 or broad money. That's M1 plus the little bit less liquid deposits, including savings and small time deposits. So this figure shows us the major kinds of monetary aggregates that we usually talk about when we try to talk about measuring the money supply. Now, money demand is a little different, and it's not unusual that students have a hard time getting a good handle on money demand. But think of it in personal terms. When do you personally demand money? When do you withdraw money, say deposits out of your checking account? And, does it tend to change seasonally? Do you spend more and demand more money, say during the Christmas years, the Christmas months? So does it change seasonally? Does it change during the month? Do you have to pay bills at the end of the month, and so you demand money a little more? So when you think about money demand, think about what motivates you for the various kinds of transactions that you engage in. And what we find is that money demand tends to be proportional to an individual's income. That is, depending upon how much income you might have, will determine what your money demand might be. So we're going to refer to money demand as capital M for money, and we'll put a little d at the top so that it signifies the money demand. And what we'll find is that money demand is pretty much some proportion, we'll call it L for that proportion. It tends to be a constant, but we'll just let it be capital L, some proportion of the nominal income that you experience. And we're going to say the nominal income is the price times the income. And that ought to make sense because the income, and of course in the United States, is the GDP. We like to think of it as, a close substitute for the income. And P is nothing more than the price level. So we would expect that money demand has something to do with the GDP and the price level in the economy. So how much we demand money is going to be some proportion of whatever GDP is. So, for example, if GDP should grow, you might expect that people might have more demand for transactions of, purchasing goods and services. And so we would expect money demand perhaps to go up. So here's an example. A rise in the national dollar income, nominal income, will cause a proportional increase in transactions and in aggregate money demand as a result. So we know what money demand is. Suppose we were to take this equation and divide through by the price level. So we're going to divide both sides by the price level, which is equal to the demand for real money balances. So real money balances, notice I'm saying real here because I'm taking the money supply and I'm dividing by the money level. And so notice units are going to disappear here. And so we're really talking about real money balances. And this is going to be a measure of the purchasing power of M1 in terms of goods and services. So now that I have money on one side of the equation, real money specifically, and I have real income on the other side, think of GDP, well, this should give me some idea of the demand for real money balances being strictly at some proportion, L, to the real income in the nation. Now, we learn in all of our economic classes that we always expect the supply to equal demand. Well, that's as true in money as well. So the demand for money, which is the demand that applies for transactions, so the demand for money should equal the money supply in equilibrium. And so let's go ahead and set those equations equal. I'm going to set the money supply, or M, equal to money demand, which is just the price times the income. And again, we're going to still think of in real terms, and we're going to divide both sides of the equation by the money level, the price level. And so on one side of the equation now, we have the real money supply, and it's going to equal to the real money demand, or real transactions. So all we have now is just the real money supply equaling some proportion of real income. Now, all we're going to do now is just solve for the price level. And so what we have here are expressions for the price level in the United States and in Europe. And what we have now and what we're learning is that the price level ought to equal, for example, in the United States, the money supply that's in the economy divided by money demand, which is some proportion of the national income. So price levels, now we have some kind of an equation now that helps us to understand what the price level ought to be. This is the fundamental equation of a monetary model for the price level. So in the long run, we're going to assume prices are flexible and will adjust to put the money market in equilibrium. The money market, of course, being the money demand and money supply. This is just a simple example. Let's suppose that the money supply in circulation, the nominal money supply, raises by some factor of 100, but that the real income, Y, stays the same. What this means then is that we're going to have much more money, M over P, chasing the exact same quantity of goods. What does that mean? Well, that leads to inflation in the long run. And inflation in the long run means that the price level is going to rise, in this case, by a factor of 100. So now what we know is that if we know what the money supply is in a nation and we know what the real income of the nation is, then we can predict its price level. And how do we do that? We do that according to this equation. So now let's move on and see if we can come up with an understanding of how this impacts the exchange rate. Now let's just take the price levels here and replace it with our new equation of the money supply divided by real income. And notice that these equations, what we have here is that the price level for the United States is equal to the money supply of the U.S. divided by the real money demand in the U.S. And so now what we do is we simplify the equation, and what we have finally on the right-hand side is we have the ratio of the money supply in the two nations divided by the ratio of the money demand in the two nations. And what this is, in essence, is the relative nominal money supplies divided by the relative real money demands. Now, this is a powerful equation because it tells us about the monetary approach to exchange rates. The monetary approach being that the exchange rates are fundamentally a function of the money supply in the two nations and the relative real money demands. So let's play with this equation a little bit. Let's suppose that the U.S. money supply increases. What do we expect to have happen to the exchange rate? Well, if the money supply in the United States increases, we can look at this equation and we notice that the only impact this should have on exchange rates is that this variable should actually cause the exchange rates to increase. which of course means a depreciation in the United States. So when the right-hand side increases due to the nominal money supply increasing, this causes an increase in the exchange rate. And this means that the US dollar is actually going to depreciate against the euro. Now let's suppose the US real income level increases, all else being equal. That means that on the right-hand side that we're going to experience a decrease, that is, the U.S. real money demand is going to increase relative to Europe. And this causes the exchange rate to decrease. The U.S. dollar appreciates again against the euro. You begin to see the power of this equation. If someone asks us any question about money demand in either of the two countries or about the money supply, all we need to do is to go to this equation, take a close look at it, and analyze it, and recognize what the impact is going to be on the exchange rate. So again, another example might be what would happen if the euro money supply actually increased. Well, we can see that that would cause the relative money supply on the right-hand side to actually decrease. Remember, if the denominator increases, then the entire ratio is going to increase. So the money supply divided by the money supply in Europe, that value is actually going to decrease if the money supply in Europe increases. So that's going to cause the exchange rate to actually decrease, meaning, of course, that the exchange rate appreciates in the United States. Now what we're going to do is the same thing we did for the price level. Remember, for the price level, we analyzed how the price level could change, and that changing price level we called inflation, and we represented that changing price level of inflation, we represented it with the Greek letter pi. Now we're going to do the same thing for the money supply. We're going to talk about its growth rate, and we're going to call that variable mu, the Greek letter mu. And we'll do the exact same thing for the growth rate of real income in the United States, and we'll call it G. We use the Greek letter and G characteristically in economics, both for the money supply as well as for the growth rate of real income. So this is standard nomenclature in economics. If you see mu, we always have that representing the increase in the money supply. If we see G, we typically mean the growth rate of real income. And we calculate this growth rate just like we would calculate any change. We take, for example, the money supply at point T plus 1, we subtract it off at point T, and we divide it by the original value of the money supply at time T. And this gives us the growth rate of the money supply. Again, mu in the United States at time T. The same thing for the real income in the United States, represented by the letter G. And it in the United States at time T is nothing more than the real income at time T plus 1 minus the real income at time T, all divided by the real income at time T. Now, remember that the price is equal to the money supply divided by money demand. And so we're now just going to analyze the rate of change of both the price level as well as the money supply and the money demand, or real income growth rate of G. But we know what the growth rate of P is. It's just inflation. We calculated that earlier. So that's just pi of US. And so we also know through calculus, but we didn't go through the details, that when we calculate the growth rate of a ratio, for example here, a ratio of the money supply divided by money demand, we know that we can just simply take the growth rate and subtract the growth rate of the two. So what we know from this is that inflation should equal the growth rate of the money supply minus the growth rate of money demand. Or in other words, pi should be equal to mu minus G. So we've learned another very powerful equation, that the inflation in the United States should equal the growth of the money supply, mu, minus the growth of real income of G. Of course, we do this exact same thing to the European nation. So we know also that the inflation in Europe is equal to the money growth in Europe minus the real income growth in Europe. And we can play with this equation a little bit. Let's suppose that the money growth rate is actually higher than the income growth rate. Well, that would mean that mu is greater than g. And so when we subtract mu from g, we would expect that number to be positive. And this, of course, leads to inflation. We have a saying for that. We say that more money tends to chase after fewer goods and leads to inflation. Now we put all the equations together. We know what the inflation is equal to in the United States. It's equal to mu minus g. And we know what the inflation in Europe is equal to. It's equal to mu in Europe minus g in Europe. So putting all this together, we get that the inflation differential is equal to the difference in mu minus g in the United States minus mu minus g in Europe. So what does this tell us? Well, we found out earlier that the change or the appreciation or depreciation of the exchange rate was equal to pi minus mu. And so what we now have is that the exchange rate or the depreciation of the nominal exchange rate, the rate of depreciation of the nominal exchange rate is equal to the differential in nominal money supply growth rates minus the differential in real output growth rates. Very powerful equations. These equations have now become our models. We are now able to explain what causes the exchange rate to actually change, or the rate of depreciation of the nominal exchange rate. It's going to be a function of the differentials of the nominal money supply growth rates and the differential in the real output growth rates. Here's an example. Here's the intuition behind the equation that we just took a look at. If the United States has a looser monetary policy and allows the money supply to increase in the long run, measured by a faster money growth rate, the dollar will depreciate more rapidly, all else being equal. If the U.S. economy grows faster in the long run, the dollar will depreciate more rapidly. Remember, when the economy grows faster, money demand grows faster. And so we would expect Y to grow faster. And so this would explain why the differential in the growth rates would increase. So remember that when they ask you questions about what you would expect of a looser monetary policy, think in terms of these equations and take a look at the equations and calculate what you would expect the impact to be on the exchange rates. Here's an example. If Europe has a 5% annual money rate of change and a 2% rate of change of real income, then its inflation is 5 minus 2%, right? So it's equal to 3%. If the U.S. has a 6% money rate of change and a 2% rate of change of real income, then its inflation should be 4%. And the rate of depreciation of the dollar would be U.S. inflation minus European inflation, or we would expect it to be 1% per year. Here's another example of the growth rate of real income. Let's say in the U.S. it increases from 2 to 5%. U.S. inflation equals the money growth rate of 6% minus the new real income growth rate of 5%. What do we expect about inflation? We would expect a 1% per year. Now, the rate of dollar depreciation is U.S. inflation minus European inflation. So we would expect it to be minus 2% per year. That means the U.S. dollar now appreciates at 2% per year. And this is going to be very close to one of the questions that are asked in the homework assignment. So what we're going to do here is we're going to use this monetary model for forecasting in the long run. And we're going to ask what path exchange rates might follow, assuming, of course, that prices are flexible and that purchasing power parity actually holds. So here's an example of forecasting with exchange rates. So we'll let the U.S. and European real income growth rates equal 0%. And we'll say that the European price level is held constant and European inflation is exactly 0. So we're going to consider two separate cases. In one scenario, we're going to assume a one-time increase in the money supply. Now, keep in mind that with a one-time increase in the money supply, we shouldn't get a growth rate change. That is, inflation shouldn't change with a one-time. Only when you have an increasing money supply do you get an increase in the actual growth rate of the money supply, which we now call money growth. So that's what we'll consider in the second case scenario, an increase in the rate of money growth, where it's not just a one-time increase in money supply, it's a continual increase in the money growth rate. Here's case 1, a one-time increase in the money supply. So let's assume 10% increase in M, the money supply. Now, we're assuming that income is held constant, and if income is held constant, that must mean that M over P must also be constant. So if M over P is constant, that must mean that the price level itself must change to contrast the money supply increase. So it must move in the same proportion, meaning, of course, that there must be a 10% increase in the price level as well. So purchasing price parity implies that the exchange rate, E, and the price level, P, must move in the exact same direction, or in the same proportion, So, well, in the same direction as well. But all of this implies that there is an increase of 10% in the exchange rate as well. Now, that's case 1, where you have a one-time increase in the money supply. So again, because it's a one-time increase in the money supply and Y is held constant, we have to have the exact same percentage increase in the price level and therefore this exact same percentage increase in the exchange rate. Now let's take a look at the case where we have an increase in the rate of money growth. So at time t, the United States or the Federal Reserve decides that they're going to increase the rate of money supply growth to rate of mu plus delta mu, delta meaning a change in mu, from a steady fixed rate of just mu. What does this mean? Let's go through the scenario. The money supply M is growing at a constant rate. That means that real money balances, again, must remain constant because we're assuming that Y remains constant. So if that's true, then that must mean that M over P being constant means that the price level itself has to be moving in the exact same proportion as money itself. So P is always some constant multiple of M. Now, this means that purchasing power parity implies that the exchange rate E and the price level P move in the exact same proportion. So E, the exchange rate, is always a constant multiple of the price level, and hence of M, the money supply. Let's take a look at what that means graphically. So here we have a graph of the money supply. And notice along the x-axis we have time. So this time here is representing how the money supply changes over time. So this notice that the slope here represents mu because it's the growth rate of the money supply, being the first derivative. So this slope here is constant until we get to time t, where the money supply the rate of change in the money supply begins to change. So the rate of growth of money supply increases right at time t, and it increases by delta mu. So again, since the rate of change is changing, we would expect the slope to change and at time t, and it does. So right at time t, the slope begins to increase, and this represents the new growth rate of the money supply. Notice it's increased. It's steeper. Real money balances, on the other hand, have stayed constant, even at point t, at time when the money supply changes. It's constant real money balances, which is M over P, because we're assuming that real income, which M over P is equal to, is constant. So if Y is constant, M over P must be constant. So even at time t, when money balances or the money supply begins to change, we would expect that real money balances remain constant. But we wouldn't expect P, the price level, to change. So here we have the price level in the economy at time t. Notice that even though real money balances remain the same, we know that that must mean, since M is changing, that P must change proportionately. It must change exactly as the money supply itself changes. And so we have the growth rate of mu going on here, and at time t, when we add the delta mu, notice that the rate of inflation increases at this point. And when the rate of inflation increases, of course, we get a different slope, or a steeper slope, because it's increased. And so here is our steeper slope of the price level. Notice this represents inflation now, because it's the price level. Up here, this mu, it represents the growth rate of the money supply, but this really represents inflation. This is kind of a little misleading. This shouldn't say the growth rate mu. It's saying that because that's what we're changing up above. But this slope here represents inflation, and of course represents the rate of inflation of the variable pi. And finally, according to our model, this impacts the exchange rate. So when the growth rate of the money supply changes at time t, we would expect the exchange rate to change right along at the same proportion as the money supply. As the price level that changes over here. So the price level has changed. We again expect the exchange rate to increase accordingly. So we can see the ultimate impact of a change in the growth rate of the money supply. We've changed it at time t. The money supply increases. The real money balances didn't, but that had to mean that the price level had to accommodate it, and the price level changed, resulting in a higher inflation rate, and that again impacted the exchange rate. And we